welcome Luis Rodriguez. I guess I pronounced that correctly. Is it Spanish?
Yep.
Right. Cool.
Yes. You got it.
Cool. Yeah. So welcome to this interview. My name is Nelson. I'm one of the Docker captains, and I just want to really talk to you about Docker and how you and your company use Docker in your workflow. So do you want to start by tell us who you are and what you do?
Yeah, so I'm Luis, and I work as part of a team of flight software engineers on the NASA Double Asteroid and Redirection Test. And so this is a mission that it has, at this point, successfully demonstrated that humanity is prepared to deflect an asteroid if one were ever coming toward us, right? And that doesn't necessarily mean that there is one coming. There isn't at all. But we wanted to be able to test the technology, right? Just in case we are ever in a predicament where we do need it, to be able to, using pretty much just momentum, right? Like building a spacecraft, aiming it at an asteroid and then hitting it so that we can slightly deviate it from its current course, demonstrate that humanity can do that and that we have the means to do it. And so as part of the flight software team, I am one of a group of several that work on the, as we call it, the glue of the spacecraft. So we're kind of like we call it the glue, and then we also call ourselves the bit shifters, because what we do is grab bits of information from one instrument and kind of ship it over to another set of software that's making predictions on our current trajectory, or providing just housekeeping telemetry data and things like that on the status of the spacecraft, as well as commanding the spacecraft to do certain things, right, throughout the span of its mission. So in order to develop such a, rigorous mission, you kind of have to have a good development environment as a flight software developer. And hardware is not always available for you to test in. So back when we first started the mission, we decided to containerize using Docker all of the different components that make up what we call a spacecraft on a laptop. Mm-hmm. And so that spacecraft on a laptop is made up of the flight software component, which is what you load onto the spacecraft, the testbed software component, which is emulation software mimicking the functionality of, for example, like the radio or the camera that's taking images. And then being able to load, as a developer, your flight software onto this still environment, still for software in the loop that we call the spacecraft on laptop. And then just be able to run our test on, like, okay, am I configuring the camera correctly? Am I getting frames from the radio how I expect to get them? And to do that and be able to ship around that environment as easily as we could, we decided let's use Docker and containers. And so that's kind of like the main way that we used it. And then what that facilitated was not only an environment for us to develop in and for us to test the flight software and the testbed software in, but also an environment in which we could replicate a developer's, environment within a set of CI, continuous integration pipelines. So being able to instantiate the spacecraft on a laptop, run a ton of regression tests, and then more or less assess, did we break it? Did we not break it? What we introduced, does it still work on another machine? Things like that. So that's like the main use of how we used Dockers and containers in Dart.
Wow, that's quite interesting. So you see that picture there that I see behind you. What is that?
Yeah, so the picture right on top is actually recently in September, the Dart spacecraft actually completed its mission of impacting an asteroid. And so as we were approaching during the last 4 hours of the mission, we're constantly taking pictures once a second of the target of the asteroid. And that is the last full all-encompassing image that we took of the Dimorphos, which is so our target was a binary system, which is just two asteroids orbiting around each other. Mm-hmm. The bigger one called Didymos, the smaller one called Dimorphos. Dimorphos is the one pictured there, which is the one we were trying to hit. And we continued to take pictures well past after that one, where you can kind of see getting closer and closer to the asteroid until you hit it, and then you completely lose telemetry. And so this is one of those few cases in space where you actually want to stop getting status telemetry from your spacecraft. You wanted to just say, I'm gone, right? So that was pretty exciting. And And yeah, that's what that thing up there is.
Wow, that's amazing. So one thing that I'm quite interesting to know is, so let's just go a little bit back in time, right? So how
Hmm.
was life before Docker for you guys?
Okay. Well, so before we started containerizing things and using Docker as our tool and Docker Compose, right? Because we use Docker Compose as well to actually stand up all these stills. It was just kind of tricky to kind of maintain an environment where we could in a dependable manner instantiate our flight software on our testbed software and our little ground station so that we could replicate the SIL. So we would have to actually, first of all, we compile our code inside containers. So like we have all our toolings inside our containers, and we just stand up a container and compile our flight software, our testbed software image, which is testbed software in C++ and flight software written in C. And so we before we had this constant back and forth of like, oh, it's compiling on my machine, but it's not compiling on yours. It's like, oh, do you have this dependency? Do you not have this dependency? Right? The big question Docker has always tried to answer, which is like, it works on my machine, but it doesn't work on yours, right? Yes. And so that was the question we were trying to answer. And so we were like, okay, let's try and use a dependable environment, containers, right? Where I can just give you a container tag, and then you use that to compile your flight software image. So that was one of the problems we solved. Mm-hmm. And then the other problem was, okay, now you have a compiled flight software image and a compiled testbed software image, but you want to run them in a dependable manner, right? And you want to run maybe more than one of them, right? Like maybe I want to run multiple of these stills. And so these containers need to talk to each other. So we stand up a flight software container and a testbed software container. They talk to each other, and now we can have like different discrete versions of a spacecraft on a laptop. And so before we couldn't do that, right? Before we kind of were, if we wanted to implement this in like a continuous integration pipeline, we had to depend on our Bamboo agents to kind of just have all this set up already, have all the dependencies that they needed. Whereas with containers and Docker, we could just say, okay, we just need Docker on the agent, and then everything else is solved for because we just give it the tags that we needed to use, right? The image tags. And so that became a lot easier to kind of keep everything packaged together. And when something did break in my machine and it was like, oh, it broke on my machine, but not on yours, the question was no longer, what dependency don't you have? Yeah. It was typically just like, are you using the right tag, right? And so then you move your tag and then you're good, right? So, yeah.
Right, cool. And in terms of, so if we take the asteroid example, so, it took a picture in space. So if we take that scenario and then just try and see how would we test it locally. So what kind of stuff are you doing for testing all of your stuff?
Yeah. So the heavy lifting, so like the actual testing of the algorithms that do some of the guiding, for example, to the asteroid, right? Because as we're guiding ourselves, we're taking pictures and we're using the pictures, we're processing the pictures to kind of find centroids of where the asteroid is in space, feeding that into a navigation algorithm, and then it does the corrections. In order for that to happen, we usually test that on hardware because there's like things like we had simulations, right, where because we don't actually have an asteroid, we had to kind of render these images of what the asteroid would look like, and then we had like a whole emulation for that. But most of that testing actually happened on hardware. The testing that is the closest we did to a completely software emulated environment was not really closed loop. It was more of for example, in order for us to configure the camera to the right settings, the detector and the telescope to the right settings to take images of the asteroid, you need to send commands to the flight software. A specific application within the flight software handles those commands and configures the detector. In reality, in an emulated space, so before you hop on a hardware testbed, you need to make sure you're doing that correctly, and you could do that in the SIL. So we could emulate what the detector configures itself to when you give it a certain command. And so that kind of testing we were able to do on the SIL, where I would, for example, implement a new command to set the integration time and the gain of the telescope for a specific test. And so I would go ahead and send a command to my SIL completely emulated. The detector emulation would then tell me, yes, you configured me correctly, or no, something went wrong. And so we could do that testing on a completely emulated environment and then move over to the hardware where there was actually more of the pipelining required to configure the detector, and that part was tested for, so it should work on hardware. Yeah. But then the rest of it, like, actually getting images and running our algorithms and all that, that ran on the hardware because it was a lot more computationally intensive and required a lot more, just making sure that it works on hardware. So we that's kind of like one of the distinctions and one of the compromises that we knew we were making going into this, into this realm of using containers and things like that. Yeah.
Right. So if I was to, let's say I was to join your company, do I need like to have like a beefy machine in order to run these containers, or?
No, typically not. I mean, I think I don't think you need beefy machines. So most of the work that we did actually, because why not virtualize, right? So one of the things we ended up doing, at first we were working on our own, like off of our own laptops, right? So just like a Mac OS or whatever. But eventually we moved to having like Linux VMs and, nothing beefy, nothing out of the ordinary, just VMs that we could more, I guess, easily control in terms of the Docker setup. So like actually installing Docker and things like that.
Yeah.
And then we would run in those VMs, and those were never beefy. I mean, it's just like a normal laptop you could buy off the shelf, right? There's nothing crazy going on there, and no
interesting.
Crazy resources. It's just
cool. And in terms of the interaction of these containers, so you mentioned about Docker Compose. So how do you use Docker Compose in your workflow?
Yeah, so when we stand up our kind of emulated spacecraft, we are running flight software, testbed software, and the emulated ground station, all within within different images and on different containers, right? And so to orchestrate them coming up, we use Docker Compose because we didn't need anything, very heavy like Kubernetes or anything like that. We just needed something simple, and so Docker Compose was an easy way to go. One, because it was like within the Docker toolset, and two, because it was very easy to just stand up, write up the YAML file and then have your kind of like your container network set up for you and all that. So that's the way we decided to go. And the interface really is between like the ground station communicates to the testbed software container, which is emulating things like the radio, right? So you send a command from your ground station to the testbed software radio emulation, which is hooked up via a container, like container network. And then that produces, like, it sends a frame, like a command frame, over to the flight software container, which then processes that frame and it replies with, like, say, a downlink telemetry packet. And then that goes to the testbed software radio emulation, which then talks to the ground software. So it's kind of like linear. The ground container to the testbed software container to the flight software container and back. And that was kind of our network setup within, and all that was done, right, orchestrated by the Docker Compose file and Docker Compose in the back. So
nice. So you've said obviously you don't need of Kubernetes. How does deployment works in your world?
So that's a very interesting question. Like we are unorthodox in that we don't really have like a deployment that we need to make, right? Like we don't have running instance of running, or at least in Dart, we did not have running instances of the SIL. We were just standing them up as we needed them and then shutting them down. So there was really no deployment. That deployment only went as far as, you update your flight software and you uprev a tag on the container image, and then that container image is ready for other people to use if they want to use it, right? But there was really no constantly running instance of the SIL that we then needed to switch in or anything like that. And I think that's what allowed us to use, I don't want to say primitive, but like simpler tools, because we didn't need to get that complicated for our use case. So, yeah.
Nice, cool. And one question for you: what is your favorite feature on Docker that you absolutely love and you can't live without it?
That's a good question. I don't know. I like the simplicity of Docker
Mm-hmm.
Compose. Like I will say that there are other tools there, right? There are other container tools, and I feel like one of the things that I've seen from kind of poking at other container tools is that Docker Compose, the simplicity of Docker Compose and the use of Docker Compose is kind of not very fleshed out. It's either a really complicated tool or Docker Compose to me.
Yeah,
So
yeah.
that's even when I'm exploring with other containers, other container infrastructures, and things like that, I usually end up using Docker Compose to hook up to whatever it is, because it's what I've grown to feel comfortable with, and I feel just an really easy interface. So
Yeah,
Docker Compose
yeah.
probably.
It's just amazing how you could just spin up an entire environment locally, right? So you could tell me the same Docker Compose, and I just run it, and it just works. Instead of me having to
Exactly.
know, oh, I need this plugin or I need this plugin, and then how do I connect them and whatnot. You could just write one definition how everything is connected, and off you go. I think it's one of my favorites as well, to be honest.
Yeah, yeah, and I feel like the chosen config file for a Docker Compose, like YAML, is also just very legible.
Mm-hmm.
So it was like a good choice to go with that, because it's like even if you haven't really used Docker Compose, I feel like reading a Docker Compose file is pretty self-explanatory.
Mm-hmm.
So I think that's also very useful.
Cool. And what are the next steps now for you in terms of what you're developing, and how do you see Docker affecting your development and moving it forward? How do you see the future?
So fortunately, in this case,
Mm-hmm.
our spacecraft is now dust and crashed into a space rock.
Okay.
So at this point, I think we're pretty much ramping down. With like we had our own private registry and all that,
Mm-hmm.
and all those things are kind of coming down, and we're just kind of keeping things for bookkeeping and things like that. But right now, I don't know. I know that there's new missions coming up,
Mm-hmm.
and new projects that we're all working on, and so moving forward, I know that we're considering different things in terms of containers and how we use containers. But one thing that is going to stick around is the use of Docker Compose again, and so we are maybe wrapping some of those things just because. We want to make it as easy for the user as possible to kind of use Docker Compose, and we are moving towards a new workflow where a user is using Docker Compose, but we don't want them to know that. Like we want it to be completely them to completely be agnostic to it, in the sense of like they want to stand up a SIL, and we just give them the tools to stand up a SIL, and hopefully they have as little problem doing that as possible. So that was a long, weird way of saying I think we're going to continue to use Docker Compose
Okay.
to kind of to do our orchestration, because again, it's limited. But in terms of like containers use and all that, I think some of these missions are still ramping up and things like that. So we're kind of doing our due diligence in what tools we use and what tools we don't. Yeah.
Nice. And is it Docker something which is widely used across the engineering teams, or is it mainly your team,
Say
or
again.
is it Docker used amongst the engineering team, or is it just your team that adopted Docker?
For Dart, it was mostly our team. Yeah,
Okay.
it's just a flight software team, because I mean our team is very multifaceted in the sense that we are like the software hub. But I mean there's other teams working on software too. Don't get me wrong,
Yeah.
like the ground software and the testbed software. But there's a lot of teams that work software, but we're kind of sitting in the center of like the spacecraft interfaces. So we decided to use Docker. Other teams like the hardware team, the thermal team, they don't use software, right? So they don't use Docker
Right.
or containers or anything. So I think APL, the Applied Physics Lab where I work, there's a lot of different projects going on where we work in space, but we work on other things too. And I've had the opportunity to listen in on other projects and things like that, and I know that some of them use Docker, some of them use container tooling, some of them so I know that it is used, but I don't know. I wouldn't be able to tell you how widely outside of just our specific case. So
Cool. Listen, Luis, thank you so much for this interview. Is there anything that you want to say to the viewers?
No, I guess I would just encourage you, if you all haven't seen it, just go on YouTube or anything and watch like the last maybe 10, 20 seconds of the impact video for the DART mission, because it was very exciting. And I think, just history in the making, right? Hitting an asteroid. So yeah, go check it out if you haven't done that.
Cool.
It's pretty cool. And also, I will say in the DockerCon 2018, the flight software lead at the time gave a presentation about our use in Docker and gave a demo and all that. So I would encourage folks to go check that out too, if you're more curious about the actual details of how we actually use SIL and Docker and containers in Dart.
Cool. That seems an amazing field to look at, and we'll definitely make sure to share the links so that the viewers can absolutely see what you guys are up to. Cool.
Sounds good.
Thanks a lot, and I'll see you around.
All right.
All right. Yeah.